All right, in this video, we are going to be talking about the range and the interquartile range. If you remember from class, we said the range is when you subtract or find the difference between the greatest and the smallest. So you're going to subtract the smallest number in your data from the largest. Subtract the smallest from the largest. There's a little song that we sing to remind us how to find the range. We've already talked about that the median separates the data exactly in half. So some new terms today: lower quartile. It's the median of the lower half of the set of data. So guess what? Upper quartile is the median from the upper half. So when we look at some numbers in a minute, it'll be easier to understand what I mean by the lower quartile and the upper quartile. Then there is this other quartile called the interquartile range. So if we have a lower and we have an upper, then we're going to find the range, which again means the difference, the subtraction between, the difference between the upper quartile and the lower quartile. So you'll say upper quartile minus lower quartile, and that will equal the interquartile. And I'm going to use IQ for interquartile. We've mentioned that sometimes there are outliers. And here is the actual math behind determining what numbers are outliers. If the data is more than half, 1.5 times the value of the interquartile range. If it's more than 1.5 times the number you found for the IQ, if it's more than that, IQ times 1.5, when you find that product and you add it to the upper quartile, any number bigger than the result of adding this to the upper quartile would be an outlier that's too big. Or if we do this product and we subtract it from the lower quartile, any number smaller than that result is also an outlier. It will make more sense when we see it with a number. So let's move on down to our example. All right, for example A, the first thing to do is to list your numbers from least to greatest. And when you do that, it'll be very easy to find the range. It'll be 21, the greatest, minus 2, which gives us a range of 19. Now let's find the median. So we have 8 numbers. So between 12 and 14 is the median. You can do the math if you didn't realize that it's going to give us 13. So the number between is 13. So 13 is the median. Moving on to find the upper quartile, the upper and lower quartiles. So lined up, since there were 8 terms, we've already established this is the middle. So you have 2 to the left and 2 to the right. Our upper quartile is the average between 14 and 17. And that's going to give us about 15.5. That's the upper quartile. The lower quartile falls between 3 and 8. So add those and divide by 2, and that gives us about 5.5. So that's the upper quartile and the lower quartile. So to find the interquartile range, the IQ is the upper quartile minus the lower quartile. So 15.5 minus 5.5 is going to give us an interquartile range of 10. Now, let's show how to test for an outlier. I don't believe there is one in this problem, but here's how we check. We'll take 10 and we will multiply that times 1.5, which gives us 15. So when we take the upper quartile, 15 plus 15, or 15.5 plus 15, that gives us 30. If there was a number greater than 30, so outliers would be greater than 30, or 30.5 actually. Where did I get 30.5? I took my 15 from multiplying times 1.5 and I added it to the upper quartile. And if it's less than 5.5 minus 15. Well, of course, 5.5 minus 15 is going to give us a negative number. So negative 9.5. So if you had a number less than negative 9.5, those would be outliers. So there are not any outliers for this set of data. So moving on to example B, right here, we're at B. They gave us this information in a stem and leaf. So let's take the time to, well, we don't really need to rewrite them because they're already from least to greatest. But how many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So halfway between 19, that would be 9. So number 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 42 is going to be the median. To find our range, the whole big range is going to be the greatest, which is 56, minus 22, the smallest, so it's a range of 34. So to find the upper quartile and the lower quartile, we have to find the halfway points between those two. So to split the lower half, we stop at 31, so the lower quartile is 31. The upper quartile, we have 4 to the left and 4 to the right, so 48 lands in the middle of the upper quartile. And the interquartile range, the IQ, will be 48 minus 31, which is 17. And let's check for outliers. So when looking for outliers, we have to say 1.5 times our interquartile range, and that gives us 25.5. So from the lower quartile, 31 minus 25.5 is 5.5, and the lowest number we have is 22, so it's not an outlier. We have to check 48 and add 25.5, which would be 73.5, and our greatest number was 56. So there are not any outliers. But I'm showing you the process to look to check. If we had had 80, 80 would have been an outlier because it's greater than 73.5. Or if we'd had the number 2, it would be an outlier because it's less than 5.5. So you multiply 1.5 times the interquartile range, then take that number, the result of the multiplication, subtract it from the lowest and add it to the largest. And any number bigger or lower makes an outlier. All right, let's work this next problem together. We have 2 sets of data. This is called a back-to-back stem and leaf. We have low temperature and high temperatures. So the first thing we're going to need to do is tackle one at a time. So let's take care of the lows first. I need to know the range or the median. It doesn't matter which one you do first. We need the median. We need the lower quartile range. We need the upper quartile range. We are going to need to know the interquartile. And I would like to check for outliers, just for the practice. All right, let's change colors. Let's go. Here we go. The range for the low temps. The smallest number here is 50. The largest number here is 80. So that means we have a range of 30 degrees. We know it's degrees Fahrenheit because of the key. Remember, this is your key at the bottom. So 30 degrees Fahrenheit. The median, I need to find the number in the middle. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 numbers. So the 8th term, 4, 5, 6, 7, 8th term ought to be the median, which would be 73. All right, so I have 7 terms to the left of my median. So that means the term in the middle would be 59. That's 3, 1, 2, 3. And then I have 1, 2, 3 above it. So 59 is my lower quartile. My upper quartile, I should have 7, so count 3, and 76 makes the median of my upper quartile. And then I need the interquartile, so we subtract 76 minus 59, and that's going to give us 17 for our interquartile. So 1.5 times 17. Let's see if we have any outliers. 1.5 times 17 is 25.5. So when you add 25.5 to 59, this will be me testing it. Test for outliers. 59, excuse me, that's the lower quartile, so subtract 25.5 and you get 33.5, and I didn't have any numbers less than 50, so there's no low outliers. And then you say 76 plus 25.5, and I don't have any numbers on this one greater than 80. So had it been greater than 101.5, it would have been an outlier. But for our low temps, 80 was our low. So there are no outliers for the lows. Now, I have used up all my space. I'm going to need to erase to make room to do my high temps, but hopefully you can get a new sheet of paper or erase this information. I'm just going to erase half so that we have room to work on. Just wanted you to see how to check for outliers. Now I can split this down the middle and have room for my high temps. The range for the high, I tell you what, I'm going to leave this for you to do. So tomorrow I want you to answer all these questions. Let me know if you found any outliers and you finish checking the high temps. You all have a wonderful day.